but we're going to start off revising our ratio, rate, and proportion. Alrighty, so before we get to this example, I just want to go through what each of these things are. Okay, so we've got ratio. No, we don't have ratio. Let's try that over here. Ratio. We have rate. And we have proportion. Right now, in grade 8, you focus a little more on ratio and rate, not as much on proportion. Proportion comes in more in grade 9, but obviously it's important to just have a general background of what's going on. We're going to focus mainly on ratio and rate today. So we're not going to stress too much about proportion, but just to remind you of what it is. So both ratio and rate describe a relationship between numbers. So ratio is a description of a relationship between two values. Okay, and ratio is something, I mean, there's so many examples, but if you say, for example, think of something like when you make oros, or if you make a fruit juice from a concentrate, you add a little bit of the fruit juice or a little bit of the concentrate, and then you add water. You're doing that in a specific ratio. I know not a lot of us do that. We just pour until we're happy. But if you actually have a look, if any of you have oros or concentrate juice or anything at home, go and have a look on the label. It tells you, or it gives you a ratio that you are supposed to make your cool drink with. That's a ratio. Okay, it tells us how many parts of the whole we are working with. A rate also describes a relationship. So I'm just going to be a bit lazy here. It describes a relationship between two values, but this time it's where the units are different. Right, so in a rate, our units must be the same. So if we think back to the fruit juice example from concentrates, your units are the same. You're adding so many moles of concentrate with so many moles of water. Those are the same units. When it comes to rate, it's still the description of a relationship between two values, but the units can be different. Now, probably the most, I want to say famous, but probably the most used example of rate is speed. Okay, speed, remember, is distance over time, and those are two different units. Distance is usually in kilometers, time in hours, kilometers per hour. Anytime you see that word per, it's probably a rate. So if you go to the shops and you're buying food, it could be anything. Let's say you're buying, I've now forgotten every type of food. Let's say you're buying some oranges. If you go to the shops, sometimes they've got a price 99 Rand per kilogram. That is a rate. It's telling you how much you are paying for 1 kilogram per kilogram. If you go and buy material, they'll tell you this is 20 Rand per meter. It's giving you a Rand value per unit, per meter of material. If you think about petrol, Rands per liter. So anytime you use that word per, it's likely a rate that you are working with. Right, proportion, then also it describes this relationship between variables, and we get different types of proportion. I'm not going to stress about that now because, like I said, we're not actually focusing on proportion. We're focusing on ratio and we're focusing on rate. Right, so I don't know if you want to take a screenshot of that. I'll wait here for 10 seconds in case you do. But let's go have a look at some examples of how we now use our ratio and rate. And remember, grade 8s, if you do have questions, please just ask. I know that this is not the easiest topic, so it's important that we do ask questions as we go along. Okay, I hope we've all got our screenshots. Let's have a look at an example. Sorry, I'll give you 2 seconds. Okay. Right, so if we have a look at our first example here, we have been told it takes 15 hours for a heavy-duty truck to drive 750 kilometers. So grade 8, the second you're seeing time, distance, or speed, you need to be thinking that I'm probably going to ask you a speed, distance, time question. Right, now whenever you do speed, distance, time questions, I have a little triangle that I use that I find very helpful for these types of questions. I don't know if you've seen this triangle before. Like I said, I find it very, very useful. I still use this with my grade 12s because I think that's so useful. So speed is equal to distance over time. So this horizontal line in the middle represents division, and this vertical line down at the bottom represents multiplication. Okay, I see some answers coming through on the chat. That's awesome. I am going to get there. So guys, the way this triangle works is you isolate the variable you want. So let's say, for example, you wanted to find the speed. So speed is equal to, and now we look at distance divided by, because it's the vertical line, time. Distance over time. If, say, for example, you wanted to go and figure out what time was, so time, that is equal to distance divided by speed. And if you wanted distance, that would be speed times time. So the reason this triangle is so nice and useful is because you can work out anything from it. All right, so I can see some answers already there on the chat. Let's have a look at the question. The question says, at what average speed does it travel? Now we know that speed is equal to distance, okay, cool, over time. My pen's just being difficult, so we're just going to ignore it there. And so if we go and find the answer of this first question, we're going to take the distance that it traveled, which was the 750 kilometers. We're going to divide it by the amount of time it took, 15 hours. And a lot of you have now given an answer. Now remember, speed has a specific unit to it. So when we divide 750 by 15, we get 50. And remember, speed is in kilometers per hour. So we need to make sure our units are correct. You could also write this as 50 kilometers per hour. So you could put a P there to represent per. It doesn't really matter. I write down the first way, so kilometers with the hash slash whatever it is. And then hours, that's how I do it. kph is perfectly fine as well. There is nothing wrong with that. All right, so nice and easy. We've used our formula. We don't need to stress. Excuse me. If we have a look at 4.2.2, so the second question, it says the truck does a return trip with a lighter load in 10 hours. So if you compare your hours that you have, much quicker for the second trip. At what average speed does the truck travel on the return trip? Now, guys, if we just think about this, if it took less time, it must have been driving faster. So we know that when we go and calculate the speed, it should be a faster speed than the 50 kilometers per hour. So if we go and have a look here, we still know that speed is distance over time. The distance hasn't changed because it's just returning. So it's going back the same way it came. So 750 kilometers. But now it's taking 10 hours, not 15. So when we go and do that division, we get, excuse me, 75 kilometers per hour. And again, this answer now logically makes sense to us because the time was shorter over the same distance. It means they had to have traveled faster. So the speed had to be greater. Right, if we have a look at 4.2.3, we're going to have to read this carefully. And there's a bit of information that I'm going to give you to help us answer this question. It says, for how long could the truck continue increasing its speed and decreasing the time taken for the truck? Okay, now importantly, we need to know, not that nonsense, it's max. Yeah, my pen is just fighting with me at the moment, so if it does weird things, we're just gonna ignore it. Assuming the max speed of the truck is 100 kilometers per hour. So I don't know how many of you have ever driven behind a truck, but often there's like a yellow circle sticker on it. And that circle sticker often has a number of like 80 or 100 written in it. And that tells you what the maximum speed of your truck should be or of your vehicle is. So any vehicle that does have a sticker on it, you know how fast it can travel. Now, heavy duty trucks generally have a speed limit between 80 and 100 kilometers per hour. We're going to assume it's 100. And so the question is now asking us for how long. So how long is asking us for a time. So if we were to use our little triangle and the formulas that I wrote down earlier, time is equal to distance over speed. Okay, now we know that the distance of this trip is 750 kilometers. We've just been told, or I've just told you, that the maximum speed it can go is 100 kilometers per hour. And the reason that we're going to use the 100 kilometers per hour is because it says, for how long could the truck continue increasing its speed and decreasing the time? It can only increase its speed to its maximum. It can't go past 100. So if we can figure out what the time is at the maximum speed, we get the shortest amount of time that this truck can travel for. So if we go and divide that, we get 7,5. Now remember, we're looking for the time. So this will be in hours. You don't have to write hours. You can just use H. That's absolutely fine. But it's really important with these questions to read the question carefully. The reason I think we often struggle with these types of questions is just because sometimes there's so many words, it gets a bit confusing. So it's really important that in your test, on your exam, when you have those 5 or 10 minutes reading time before you start, read your questions really, really carefully. Identify what information you have. So do you have the speed? Do you have the distance? What information do you have? So that you can then go and answer your questions later on. And this is where, guys, it's really important that if you need to highlight certain parts of information that you feel are important, you do that, or you underline, or you do whatever you need to do. But it's really important that you read your questions carefully when it comes to ratio and rate, because like I said, that's often where we go wrong. We just don't read our questions carefully. Okay, so let's take our screenshots. If anyone has any questions, please do ask. Like I say, you're welcome to put your question in the chat. If you need to raise your hand, that's obviously absolutely fine as well. Otherwise, we're going to have a look at our next example. Okay. So our next example, we're now talking still about rate, because remember I said speed is an example of rate. And we've got just a slightly different example that we have here. So Amethyst said, my maths teacher tells us to write down the important parts of the sum. That is very, very good advice from your maths teacher, Amethyst. And I would completely agree with that. Write down your important parts. So if that means that you make a little list on the side of your test or on the side of your answer paper with, you know, speed equals, distance equals, or whatever, as long as you've got those important bits of information, you should be good to go. So that's really, really good advice, Amethyst. Thank you. All right, so guys, the first question here says, an animal shelter uses 10 kilograms of dog pellets to feed 2 small dogs for 4 weeks. Now, there's actually 2 parts to this question. So the first part of this question says, if they have 4 dogs, how long will the pellets last? And the second part of this question is saying, if they have 8 dogs, how long will the pellets last? Okay, now this is exactly what Amelia is saying. We need to be able to go to our question and pick out the important bits of information. So if we look at the question, it says if they have 4 dogs, so the question involves the number of dogs, how long will the pellets last? So I'm asking you for time. Again, my ped's gone weird, we're just going to roll with it. So dogs and time are the 2 important bits of information that I have here. Now, yes, in the question, they told us that 10 kilograms of dog food was being bought or being used, but that's actually not important here. I don't care how much dog food. I care about the number of dogs, and I care about how long it's going to last. I don't care about how much food. That's not featuring in my question. The important bit here is that there's 2 small dogs for 4 weeks. Okay, so again, with these questions, think about it logically. If you had more dogs with the same amount of food, it's going to last less time. Okay, so more dogs, same amount of food, lasts less time. And this is, I think, probably the most useful, or one of the more useful skills when it comes to these questions. Think about it logically. right? So it doesn't make sense that 10 kilograms of food is going to last 20 weeks if we now have 40 dogs. That just makes no sense. If you're starting with the same amount of food, but you're increasing the number of dogs that you need to feed, the time must decrease. All right. So when it comes to the first question of if they have 4 dogs, how long will the pellets last? Again, we're going to think about this logically. So right now we know that 2 dogs last 4 weeks. We're now doubling the number of dogs to 4, which means that logically the time should halve. So if 2 dogs is 4 weeks, if we are going to double the number of dogs to 4, it's going to last half the amount of time, so only 2 weeks. So guys, we're not trying to trick you with these questions. We're not trying to make it an illogical answer. Think about it logically. It has to last less time, and then look at the relationship between your numbers. So now when it comes to if they have 8 dogs, okay? So 8 dogs is now double 4, which means that it must now be half the amount of time that 4 dogs lasted, which means it's only going to last them 1 week. And again, think of it logically. It has to last them less time because now there's even more dogs. And again, we're not trying to trick you. Okay, so look at the relationship between your numbers. We're not trying to trick you when it comes to these questions. If you can figure out that relationship, you are absolutely good to go. Right, and it goes back to what Amitle said earlier. Pick out the important parts of your question, because that 10 kilograms was actually a useless bit of information in this question. I didn't care that it was 10 kilograms. It made no difference to me. I cared about the number of dogs, and I cared about how long it was going to last. Alrighty, so what I want you guys to try for me, just because we did do a question like this a little earlier, is I would like you guys to try for me question 5.2. It's a weird looking blocky thing that I've done here. It's not even a block. I don't know what that is, but we're just going to roll with it. Right, so I want you to try question 5.2. There's 2 parts to this question. A train took 8 hours to travel 100 kilometers. So you've been given a time and you've been given distance. The first question asks, at what speed did it travel if it took 6 hours to travel 100 kilometers? And 5.2.1 says, what is the minimum time the train can take for the same trip if it travels at its highest cruising speed of 250 kilometers per hour? Now, if that last one confuses you, go back to your screenshot of the first example we did, because it's pretty similar to the last question where we spoke about the maximum speed of that heavy duty truck. Right, I'm going to give you 2 or 3 minutes, and then we'll have a look at what we got. Remember, guys, if you've got questions, just ask, but let's give those 2 a try. Okay, I'm going to give you 1 more minute to wrap it up, and then we're going to have a look at some answers. Remember, read your questions carefully. That's the important thing here. Itandile, I see your hand.
Ma'am, I only just wanted to answer, ma'am.
Okay, no, that's perfect. Keep your hand up for me. I'm going to get some answers in a second.
Yes, ma'am.
Okay, Itandile, do you want to explain how we do these questions first? You can just do the first question, or be happy to do both. That's awesome.
Yes, ma'am. So, ma'am, the DST triangle says that we need speed. So, the formula for speed is D over T. Then we have to say speed is equal to 1,000 over 6, which is the hours, and then we have to divide that.
Good.
Ooh, ma'am, which is 166,6 or 166,7.
Awesome, well done. Okay, I'm going to do 2 decimal places. That's just what I'm used to. Guys, I hope you were listening really carefully to that, because that was a beautiful explanation, Itandile. Well done. So remember, use your triangle, substitute in what you have, and then you can go. Some of you got a slightly different answer. So Itandile, before you carry on, remember the question said 6 hours. I know the information said 8, but it goes back to what Amelia said. Look for the information that is important. Alrighty, Itandile, the second one.
Ma'am, I didn't actually understand the second one.
Okay, no, that's absolutely fine. No problem. But thank you so much for explaining the first one. Is there anyone who does? You all sorted?
Yes, ma'am.
Cool, thank you. Okay, Umar, I see your hand. You want to explain the second one for us?
Hello, ma'am.
Hi.
So they said what's the minimum time the train can take? So it's 1,000 divided by 250.
Okay, cool. So guys, just in case you're not too sure where that's coming from, time, remember, if you use your triangle like Itandile did, is the distance over speed. So sorry, Umar, say those numbers again for me.
1,000 divided by 250.
Excellent. And what did you get?
I got 4.
Perfect. So the minimum time it can take to travel that distance at its maximum speed is 4 hours. Amazing, Umar. Thank you so much. And Itandile, thank you so much. All right, so guys, remember, like I said, this was very similar to the example that we did earlier. So I said, if you were feeling a bit confused, go back to your notes. That's a really good start. But obviously, if you are struggling with something, you just let us know. All right. Liacho, I just want to make sure that you understand for the first question, it's 166,67, because remember in the question, we're dividing by 6 hours, not by the 8 hours we were given. All right, so the 8 hours was just a bit of information that they gave us. In the actual question, it asked us for 6 hours. Right, Hope, where did we get the 250? So again, if you read your question carefully, it says, if the highest cruising speed is 250 kilometers per hour. So that's where we got that 250 from. Remember, the question said, what is the minimum time the train can take? The minimum time means that it has to go at its maximum speed. It has to go as fast as it can in order to get the shortest amount of time. So I hope we're going to use that 250 kilometers per hour in order to get the minimum time. Hope that makes sense. Yeah, cool. Awesome. I'm glad we're good. Right. And it's basically what I was saying earlier. It's just reading the question, right? Sometimes we just have a moment where we've read the information and we don't go the next step and we just make a silly brain fart moment. It's fine. Okay. So that's what I'm saying with these questions. What you need to bear in mind, or what you need to actually be doing, is reading them carefully, because you all know how to take distance and divided by speed, or distance divided by time. You all know how to do that. It's just sometimes we make a really silly mistake and don't read our question properly. All right, guys, so I'm just going to wait for a second in case you need to take a screenshot. Itandile, I still see your hand. Do you still have a question, or do you have a question rather? If not, absolutely fine. But if you do, you're welcome to unmute yourself.
No, ma'am, I don't have a question.
Okay, no problem. Okay, guys, I thought there was another hand, but if okay, I don't see it anymore. But obviously, if you do have questions, just let me know. Alrighty, you guys are doing so well. All right, so I think before we get into the ratio idea, let's take a little brain break. So this is a brain break I used to do with my grade 8s. You might like it, you might not like it. We'll see what happens. But either way, take a little break, and while you are on the same page as me, so a little brain break. What we want to do for our brain break is we want to figure out what the ice skates, the chess pieces, and the gown are worth in order to make these equations true. All right, so give it a try. Let's see what you come up with. It's a little maths brain break. Where are we at? Time. I'm going to give you like 3 minutes, 4 minutes. We'll see what we come up with. It also would help if I did it. Knew what the actual answer was. Right, so we're all doing the brain break together. Yo, you guys are quick. Umar, wow. I'm like, very slow to give me. It's okay. And guys, be careful. I'm going to make it a bit bigger. Be careful where there's 2 skates and where there's only 1 chess piece. We need to take note of what that means. And remember BODMAS. Must you got the chess piece is 13. I did not get that. So let's double check that. Because remember, you'd have to use BODMAS. So 12 times 13 already gives us 156. That's quite high. Okay, so grade 8s, if you struggle with this, what I want you to remember is like it's like solving an equation. Tando, I think I'm in agreement with you. That's what I got as well. Nice, Umar. Nice. Hope, don't worry, I'm going to explain it. But like I said, what we're trying to do is we're trying to figure out what value the skates have in order to get 36. So if you're going to add 3 of the same number, we have to get 36. So what 3 same numbers do we add together to get 36? So I'm talking about this first equation here. You've got 3 of the same thing that you're adding. So what 3 identical numbers do you add together in order to get 36? So those of you that are lost, I hope that you were listening, because I've just explained the first one. What three identical numbers do we add together to get 36? So for example, 4 plus 4 plus 4 is 12, but we want 36. So what three identical numbers? Nice, guys. Okay, so there you go. So you now know that these skates up here all represent 12. So this is 12 plus 12 plus 12. What that means is now everywhere you see two skates, you know that the number is 12. So now when we get to the second equation, you need to ask yourself, 12 times what plus that same number gives us 104. So this is where things start getting a little trickier. But now you can just plug it into your calculator. You can try and see what you get as you go along. Okay, so there we go. Tando's helping us out. So Tando's saying let's do 12 times 8. Now remember, we have to use BODMAS. We have to do the times first. Oh gosh, 12 times 8 gives us 96. Okay, so this first little bit here gives us a product of 96. We then would have to add the same number. So 96 plus 8 is 104. So now I know wherever I see two chess pieces, I've got 8. But that would also mean that one chess piece is half of 8, which is 4. So now these chess pieces that I'm seeing here are all 4. Now I need to go and get the jacket thingy. I know there's a word for it. My brain's just not working tonight. Don't know. It's gone, but the clothes, the jacket. And again, think about this. 4 times what number plus 4 is going to give us 32. Down? Yeah, that sounds a little better. Thanks. Right, so Uma, nice. So Uma's helping us. 4 times 7, that gives us 28. 28 plus 4, 32. So now I've got the value of everything. I've got 7 plus 12 times 4. Again, BODMAS. 7 times 12 is 48. Plus 7 gives us 56. I did that very quickly in my mind. Does it give you 56? No, it doesn't. It gives you 54. Oh, no. Oh, my gosh. This has just gone from bad to worse. My 5 went weird. 55. Guys, are we all doing maths tonight? I'm not doing maths. You're all doing maths. Don't know what I'm doing. Cool. Nice. 55. Thank you. Clearly the term has ended and our brain, well, my brain is tired. Well done, guys. You got there so much quicker. Can't even speak English. That's where we're at. Okay, Hope, what do you mean, how do we know? So if you mean like, how do I know that these are the actual values? It's because if you think back to how you solve an equation, we're able to go and work with opposite or inverse operations or to work backwards to get to the value that I don't know. If you go and check all of these things on a calculator, you're going to get the right answer. And so we were able to work backwards from the value we knew the equation needed to be in order to get our unknowns. Now, don't stress about this, all right? It's just a fun little brain break, and you are going to do equations this year. So you're going to learn more about solving equations, and then something like this will be a lot easier to deal with. But this was just like a fun sort of exercise in terms of using your maths brain that you all have in order to figure out some unknowns. If you didn't get it, guys, don't stress. That's absolutely fine. Like I say, it's the end of term. Our brains are tired. It was something to try. And hopefully we got at least the first and second one. That's an awesome start already. Now, hopefully when you've done equations, the second and third ones will be a lot easier as well. Alrighty, guys, but let's carry on with our work. I don't know if anyone wants to take a screenshot, but I'm going to wait for like a second in case you do. Challenge your family and friends. And then we're going to have a look at some ratio questions. I love ratio. I know it's one that not everyone enjoys, but I enjoy ratio. So we're going to hopefully get all of you to enjoy it as well. Okay. Right, so remember I said guys, we're also not going to get to all of this, so please don't stress at the amount of work. I'm not going to rush you. It was just in case. So remember I said right at the start that a ratio is when we are comparing, highlighter, No? Yes. When we are comparing two or more quantities of the same kind. Now, when I say same kind, remember what I meant there was it's the same unit. So, for example, I'm looking at Lorena. I'm looking at the relationship, say, for example, between 50 Rand and 150 Rand. What is their ratio? What is the comparison between the two? Well, 50 Rand is a third of 150 Rand, or 150 Rand is 3 times as much as 50 Rand. Okay, so it's comparing these two values that have the commonality or something in common, which is their units. Now, ratios and fractions, I don't want to say are the same thing because they're not the same thing, but they do represent very similar things. A fraction is representing parts of a whole, and that's essentially what a ratio is saying. So if you had a fraction of 3/4, or really any fraction, you could write this, you could write this as a ratio of 3 to 4, right? So 3 to 4 is telling us how many parts we have in comparison to another. Hope you never have to be sorry for questions. I can guarantee you someone else, at least one other person, has the same question, if not more questions. This is how we learn. The only way you learn is to ask questions. I still ask questions all the time, right? That's the only way we're going to learn. And we're also going to only learn by making mistakes. Again, I make mistakes all the time. I couldn't do basic multiplication earlier. I got 54, not 55. This is how we do things, right? You only get better when you make mistakes and when you ask the question. So I love that you're asking questions. Keep asking questions. Hope. All right, so now that my little motivational TED talk is done, ratios are written with 2 dots. Okay, it's called a colon. This is not English. You never need to know that it's called a colon, the 2 dots, right? And it represents how many parts you're working with. So 3 colon, so 3 is 2, 7 colon is 2, 4. Every time you see those 2 little dots, you say 2. So 3 is to 7 is to 4. When you work with a ratio, okay, Lorena, I'll get you now. When you work with a ratio, we should always work with a simplified ratio, which we're going to practice in a second. But guys, at the end of the day, a ratio is a comparison between values. So Lorena, to answer your question, why is there 3? It's because I don't necessarily only have to compare 3 values. So let's take a very random example. Let's say, for example, you have 2 siblings. So you get 150 Rand pocket money, another sibling gets 50 Rand pocket money, and another sibling gets 200 Rand pocket money. Okay, just as a very random example. If you now wanted to compare the money that you're getting, you can compare all 3 of them. If you had 7 siblings, we could go and compare all 7. 7 would be very mean. 3 is generally the max we work with. But a ratio is just a way of comparison. And we don't only have to compare 2 values. We can compare more than 2 values. Right, so like I said, generally 3 is enough, but we can compare any number of values. Uma, I'm not on the same page as you, but someone else seems to be on the same page as you, so I'm glad we're there. I'm not. We're 15 over 25, where we're at. Am I just like having a bit of a moment? Oh, okay. No, I know where you're at. Okay. Sorry. Okay, see, this is why when you guys work ahead, confuse me. But yes, we're getting there. Okay, Bree, I'm glad we've got an O there. That sounds positive. Right, so guys, a ratio is just you comparing values. That's all it is. However, when we do compare these values, it should always be in simplest form, and that's what we're going to have a look at now. So if we had, for example, a fraction of 25 over 30, you guys all know how to simplify a fraction. We know that what we would need to do is we would need to find the biggest number that can divide into both. In this case, that would be 5. Cool, we're just going to move things that shouldn't be moved, because why not? Both of these can be divided by 5. And if you divide 25 by 5, let's move it to the other side. No, they can both be divided by 5. 25 divided by 5 is 5. 30 divided by 5 is 6. So whenever we're working with ratios, we are essentially simplifying a fraction. And as Bree says, if you can do the fractions, you can do the ratios. You got it. Alrighty. So this is where Uma was. I was not there yet. If 3/5 equals a/25, what is the value of a? Okay, so all we're doing here, guys, is we've got a simplified version and a non-simplified version. I don't know if non-simplified is a word, but we're rolling with it. And I'll explain, that's also not how you spell simplified. Simplified. I'll explain why these are useful in a second. But we have this. Now, remember, there's always a relationship between your numbers when you're simplifying. In the 25/30 example, we divided everything by 5. Exactly, Bree. So the question is, what am I doing to go from 5 to 25? Well, I multiplied that by 5. Now, remember fractions, what you do to the denominator, you must do to the numerator. So I need to multiply that 3 by 5 as well. And so exactly, a is equal to 15. Now, when you guys did fractions, you spoke about this idea of equivalent fractions, or fractions that mean the same thing. Sorry, I got a bit sidetracked. Okay. So fractions that have the same meaning or represent the same parts of the whole, they're just represented differently. So if we have no idea what I'm talking about, equivalent fractions would be something like a half is the same thing as 2/4, which is the same thing as 8/16, which is the same thing as 10/20. All of these fractions represent a half. We're just using different numbers, but they all represent a half. This is exactly what a ratio does. A ratio of 3:5 represents the same thing as 15:25. It's just one is non-simplified and one is simplified. But we should always, and this is anything to do in maths, we should always write our answers in the most simplified answer or simplified form. Okay, so I know we're rushing ahead, but let's also not confuse everyone, guys. I've got no problem with you guys going ahead and trying examples, but just remember that not everyone's on the same page. So let's just hold on to our answers until I get there, and then you're more than welcome to post your answers on the chat. But we don't want to confuse anyone, all right? So right, so if we do have a look at the second example, we've got 250 ml of water is added to 15 ml of cool drink syrup. What we were talking about earlier, concentrate. This is basically mixing up Oros concentrate or energetic concentrate or fruit juice concentrate. Read the label. Go and check in your cupboards just now. What is the ratio of water to syrup? Right, now, before we even get to the numbers, in a ratio question, we will give you the order in which we want the ratio to be written. So when you write these numbers down, you must have the water number first and then the syrup number. Order of a ratio is very important because the ratio tells you what you need to do. If I said to you, go and mix your Oros in a 5:2 ratio, if you had no idea what was what, that's very unhelpful. So we need to make sure it's in the correct order according to the question or according to the statement so that we know what it is we're talking about. When we now do the ratio, I'll relate it back, but it's very important that we get it in the right order. So NB means important, the order. All right. So the water was 250 ml. The syrup was 50. And I think someone had put that on the chart earlier. We've got a ratio of 250:50. You always need to simplify. So the question should now be what number can divide into both? Hopefully we know we can divide both of these by 50. And if my maths is serving me correctly tonight, 250 divided by 50 is 5. 50 divided by 50 is 1. We've got a ratio of 5:1. All right, now if we go back to the whole order is important thing. If I say to you, you're going to mix water to cool drink in a 5:1 ratio, you now know that you must have 5 parts of water to 1 part of cool drink. This was also really helpful if you want to scale up how much you're making or scale down. Let's say, for example, you now wanted to make a cool drink for your whole rugby team or your whole netball team or your whole soccer team. You're obviously going to need liters of cool drink. You can now scale it up to that. If, let's say, for example, you wanted to make cool drink for a very small amount, you can scale it down because you have this nice ratio that tells you the relationship between water and cool drink soda. And that's why ratios are so useful. Ratios used a lot in like manufacturing, whether it's cooking, baking, making materials, or whatever the case is. Ratios are really useful for that. All right, so I'm also aware that I did not let you screenshot earlier. And how my screen's not moving, so that's a fun development that we've just had. So let me make this a bit smaller so you guys can screenshot. Yeah, we got there in the end. There we go. Right, so take a screenshot of that and then we'll have a look at another example. Right, and thank you to everyone on the chat. Well done. That we all are helping each other out. Umar, well done. And Tandil, thank you. That division by 50 was spot on. Alrighty. Okay, not either. So let's have a look at example 3. There are 90 apples in a box. They will be divided among 3 families in the ratio 5:4:6. How many apples did each family receive? Now, guys, there's quite a few ways in which you can do this. But let's just think about the ratio, or what the ratio is telling me. The first family gets 5 parts. The second family gets 4 parts. The third family gets 6 parts. So the third family should be getting the most number of apples, and the second family should be getting the least number of apples because that was the smallest number in my ratio. Okay, now there's lots of different ways that you can visualize this. I quite like to draw a picture for myself. You obviously do not have to do this. I will show you the maths way to do it, but I like to draw a picture to visualize what's going on. Okay, so we've got 3 families, family 1, family 2, family 3. Family 1 is going to get 5 of these apples. 3, 4, 5. Family 2 only gets 4 of them, or 4 parts, let's say rather. But family 3 is going to get 6. Now, a ratio is all about those parts, remember? How many parts are we working with? So if we go and count the number of blocks, or if you just add up the numbers in your ratio, you get 15 parts. Now, those 15 parts represent all of the apples that I have. So it represents 90 apples. And this is essentially what you now need to start doing with a ratio. You need to find the total of the numbers in your ratio, and that's going to help us figure out how many apples each person gets. Right, now again, there's lots of different ways that you can do this. You have the number of parts each family gets. 5 parts, 4 parts, 6 parts. You know that 15 parts gives you 90 apples. But if we can work out what 1 part gets, then it's very easy for us to figure out what each family gets. So if I want to make this 1 part, I would have to divide by 15. And so I'm going to have to do the same thing on the other side. If I divide 90 by 15, I get 6 apples. And I think someone actually said that in the chat then. So every part to my ratio represents 6 apples. So these 5 parts here for family 1 is 6 apples. Every single one of those parts. Every single one of the 4 parts for family 2 is 6 apples. And every one of the 6 parts for family 3 is 6 apples. And now that you know what 1 part is, it's very easy to go figure out what each family gets. So family 1 was 5 parts, and for 5 parts, we've got 6 apples for every one of those parts. So they're going to get 30 apples. Oh, so maybe I should say family 1 here. Family 2 was represented by 4 parts, and every one of those 4 parts was 6 apples, so they get 24 apples. And family 3 had the most parts, 6 parts, where every part is 6 apples. So they're going to get 36 apples. Right, and this goes back to the discussion we had about rate. If we can figure out apples per part, or whatever per part, we're able to go and figure out what each person is going to get, or what each whatever is going to get. Okay, so now we know what each family is going to get. Remember I said family 3 should get the most and family 2 should get the least. If you check, that's the case. Right, I see Bree's hand is up and down. So I'll give you a second to think about it. 2 things. So Uma said on the chat, we can also simplify. So Uma, I quickly want you to simplify that and tell me what you get, and we'll chat about it in a second. The second thing I want you guys to do for me while I answer Bree's question is I want you to just add 30 plus 24 plus 36, and then we'll see what we get. And we'll discuss why that is in a second. Okay, Bree, what's your question?
Hi, Nan and everyone.
Hi.
I kind of got confused towards the last step where you got family 1, 5, and 6. If I may, how exactly did you get to that part?
Okay, so I just want to make sure you're confused about this part over here in yellow.
No, the family 1 equals to 5 times 6.
Okay,
That
okay, cool. So that part there, once I knew what one part was, remember I worked out that one part was 6 apples. If I go back to my ratio, the first family was represented by 5 parts. So for every one of those 5 parts, they get 6 apples. So that's why I needed to say 5 by 6. For the second family, they had 4 as their parts. So every one of those 4 parts, they got 6 apples. So 4 times 6. And then the same thing for the last family. They had 6 parts. Every one of those 6 parts is 6 apples. So we can say 6 times 6. So once you know what one part is equal to, you will multiply that part or the parts of your ratio by that value you've gotten. Does that make a bit more sense?
Yes, it does. Thank you.
Okay, awesome. Panic, sorry, my mouse has just gone weird. Okay, so if we just go back to the question I asked. So there was a simplified question and there was an adding question. Most of you have done the adding question. You've all said it adds up to 19. If you go back to what the question originally said to you, there are 90 apples in a box. So it makes sense that if I add up all the apples for all 3 of my families, I should get 90 because that's how many apples I divided amongst the families. So guys, that's one way you can check yourself. If you're not sure if your answers are correct, add them up. Does it take you back to what you originally needed to share out? It does in this case, so we're good. The second question was simplify the ratios. You guys have said to me that it simplifies to 5 is to 4 is to 6. What do you know? Look at that original ratio. 5 is to 4 is to 6. So if you were to take these answers, now remember the question didn't ask you for a ratio. It said how many apples. If you were to write these number of apples as a ratio, it would take you back to the ratio you started with. So again, another way that you can check that you've done things correctly. All right, so I'm really glad that you guys started making those connections. That is awesome. There's a lot going on here. There's lots of colors. Let's take our screenshot though, guys. And then